It's also helpful to group elements by which phase they are in at room temperature. There are several gases. In the rightmost column are the noble gases. You know one of these, helium, near the top. It's interesting that at children's birthday parties, people will fill up balloons with helium, a pure chemical, and they don't even care if one pops, spilling helium onto the children. Or if one is close to a fire that might light the helium on fire, some people don't care. Some parents will even poke a hole in the balloon after the party and breathe in helium into their lungs, which is very sensitive tissue. The reason this is okay is because all noble gases are inert. That is, they will not chemically react with any other substance. The same is true with neon and argon, both of which are put into light bulbs and allowed to heat to sometimes 10,000 degrees without any decomposition. On the other hand, fluorine, capital F, and chlorine, right next door on the periodic table, are part of a highly reactive group of elements called halogens. Chlorine has quite a history. On the negative side, it was used in World War I. It was used to kill and maim many World War I soldiers as the first chemical warfare agent. We have probably felt it sting a little bit in the swimming pool, where chlorine compounds in the water release small amounts of chlorine gas into the air. Today, chlorine is used in water to protect people because a tiny amount won't hurt us, but will kill infectious bacteria. Fluorine is even more reactive and is too difficult to handle in our daily experience. Both chlorine and fluorine form exceptionally stable compounds with other elements, and we see many of these, such as PVC plastic pipe and Teflon. Sodium chloride is everyday table salt, and sodium fluoride is put into toothpaste and fluoridated drinking water. Other important element gases are nitrogen and oxygen. Believe it or not, nitrogen is the most abundant gas in the air, 78% of the total. Oxygen is at 21%. If you are paying attention, that means that 99% of the air is nitrogen and oxygen, and all of the other gases together make up 1%. Of the two, oxygen is much more reactive than nitrogen. Oxygen will react with almost any other element or compound. When it does, it gives off heat and light, and we call it fire. So from now on, whenever you see something burning in air, assume it's a reaction of a fuel with oxygen, and we'll call it combustion. Nitrogen, the most abundant gas in our atmosphere, 78% of all air, doesn't react like oxygen to burn. It's hard to even know it's there because it won't react with almost anything. We breathe it in, it gets in our blood, but it goes out again. We just breathe it out and we never feel it. In fact, it is so inert that we use it in containers or as cold liquid to protect sensitive material from reactions with oxygen in the air. Where nitrogen becomes critically important is a source for making nitrogen compounds. For plant life, we see microorganisms in the soil and plants. For example, the root nodules of soybeans, where fixed nitrogen is in the form of nitrogen compounds like NO3. Where a great amount of plant growth is needed, like in the modern densely grown cornfield, enormously greater quantities of fixed nitrogen are required, which is done at a large chemical plant where nitrogen is extracted from the air and mixed with hydrogen to make anhydrous ammonia. The ammonia is trucked to the fields in large tanks and sprayed into the soil. Nitrogen is also a factor in air pollution because it enters hot reaction compartment of car engines along with oxygen, and when the fuel reacts with oxygen, the nitrogen when the fuel reacts with oxygen, the nitrogen reacts with the oxygen too. Car exhaust then spits out the compound NO2. This gas is very hard to breathe, severely irritating to your lungs. It can be seen sometimes hovering over large cities because NO2 is brown and will appear brownish, covering over at a distance away. In cars, trucks, catalytic converters have largely solved this pollution problem by changing the NO2 compounds back to nitrogen and oxygen before they are released. Last on our list of gases is hydrogen. It is not found in nature, but it is so plentiful in compounds that it's easily produced. I showed one way: you just run a current through water, you get hydrogen and oxygen. There's lots of hydrogen locked in water, so the only difficulty is generating enough electricity. There's also lots of hydrogen locked in oil products like natural gas. The natural gas reacted with steam generates most of the hydrogen sold today. Hydrogen has the property of being flammable, so much so that it has been used for specialized fuel uses like the booster rockets on the old space shuttles. It may one day be used for fuel in cars if it can be made more cheaply and stored more conveniently in a gas tank.